Hey pre-calculus, and welcome to our third week of distance learning. Today we will be looking at chapter 12, section 3. We're still working in our chapter pertaining to matrices, and our goals today, we're going to look at performing some operations. How do we do matrix addition and subtraction? How do you do multiplication? Something called a scalar, and then again being able to just find a product. Product means multiply, so being able to find the product of two matrices, and then realizing that if you have addition, subtraction, multiplication, all those things, you do still have to follow that order of operations that we always study in math. So the first thing, when you are doing matrix addition and subtraction, it says you can add or subtract two matrices if and only if they have the same dimensions. Now, the dimensions of a matrix tells you how many rows by how many columns. Now, rows go side to side, so we're looking horizontal. So A has 1, 2 rows by how many columns, and that's a vertical line, 1, 2. So A has the dimensions 2 by 2. B has 2 rows, horizontal rows, by 1, 2, 2 columns. Now C has 1, 2, 3 rows by 1, 2 columns. So that has the dimensions a 3 by 2. D is 1, 2, 3 rows by 2 columns. So we have 1, 2, 3 rows by 1, 2 columns. E has 1, 2, 3, 4 by 1. So those are called the dimensions of a matrix. And again, just to review, the first value. So here the 2, the 2, the 3, the 3, and the 4. It's how many horizontal lines could you draw. Those are called rows. Now the second number, it's how many columns. Columns run vertically. So A has 2, B has 2, C has 2, D has 2, and E just has 1. Now going back to this, it says you can add or subtract two matrices if and only if they have the same dimensions. If they have the same dimensions, and you can add or subtract them. To perform the operation, you add or subtract the corresponding entries. Okay, so let's go ahead and just look at 1 and 2, and that will show you what this means. It says that you can only add or subtract if you have the same dimensions. So A has the dimensions 2 by 2. B has the dimensions 2 by 2. They have the same dimensions, so yes, you can add them. A is 0, 1, negative 4, 7. Plus, you're going to add that to B. B is negative 5, 1, 0, 2. What it tells us is that we have to add the numbers that are in the same location, the corresponding entries. So 0 is in the upper left corner. I have to add that with negative 5 because that's also in the upper left corner. The sum of those two, because I'm adding, is my new upper left corner number. So 0 plus negative 5 is negative 5. 1 plus 1 is 2. Now I'm going to the second row. Negative 4 plus 0 is negative 4. 7 plus 2 is 9. You just found the sum of matrix A and matrix B. Now the next one, they want us to go ahead and subtract. Same thing with subtraction. You have to have the same dimensions. So D has the dimensions 3 by 2. C has the dimensions 3 by 2. So notice we do have those same dimensions, which you have to. So now we can go ahead and we can subtract. D, negative 2, 2. Negative 5, 1. 3, 0. D has to come first. Minus, you are subtracting matrix C. C is 1, 8 on the top. Second row is 4, 0. Negative 6, negative 2. Now again, we combine the values that are in the same spot, the corresponding entries, but this time we're subtracting. So negative 2 minus 1 more is negative 3. 2 minus 8 is negative 6. Negative 5 minus 4 more is negative 9. 1 minus 0 is 1. 3 minus a negative 6. Remember, if you have a minus a negative value, you're actually adding. So 3 plus 6 is 9. 0 minus a negative. So again, minusing a negative, you're actually adding. 0 plus 2 is 2. So there are two examples of how you can add and subtract matrices. Again, both times you had to make sure that you do have the same dimensions, and that's because you have to be able to match up your entries. Okay, now looking at multiplication. Matrix scalar multiplication. What that means is you are actually distributing a value that's called a scalar. And so it's going to look something like this. This says 4a. So just like if you were distributing, you're going to take 4 and you're going to multiply it into every single entry of a. Here is 2b. This means you take the B matrix and you distribute or you multiply every single entry by 2. So this looks like this. So 4a is 0, 1, negative 4, 7, plus 2 times b. B is negative 5, 1, 0, 2. Now this is where they mentioned at the top is one of the goals is to make sure that you are honoring the order of operations. Because if I look at this problem, the 4 and the 2, they want you to multiply. And the problem has an addition. In math, you always multiply before you add. It's following those basic order of operations. So if I'm going to multiply first, this 4 gets brought into all of the entries of matrix A. So 4 times 0 is 0. 4 times 1 is 4. 4 times negative 4 is negative 16. 4 times 7 is 28. Plus, now for B, we have to bring that 2 into everything. 2 times negative 5 is negative 10. 2 times 1 is 2. 2 times 0 is 0. 2 times 2 is 4. So we performed all of the multiplication first. We did what's called scalar multiplying. Very, very similar to distributing. Now we can go ahead and add. So now you add the entries that are in the same location. So 0 plus negative 10, that's negative 10. 4 plus 2 is 6. Negative 16 plus 0 is negative 16. 28 plus 4 is 32. Okay, so there's one where we do what's called scalar multiplication, and then we went ahead and had matrix addition afterwards. Okay, here's another example of just scalar multiplying. It's just showing you that you can also distribute or bring in a fraction. So 1/4 E means I'm taking 1/4 and I have to bring it into all of the entries of matrix E. So I take 1/4 times 8. Well, 1/4 times 8 is the same as 8 divided by 4. You get a 2. 1/4 times 1 is 1/4. It's okay to have a fraction within a matrix. 1/4 times 0 is 0. 1/4 of negative 4 is negative 1. So there again we have an example of what's called scalar multiplication. Now the next one they want us to add. A, if we look back, A had the dimensions 2 by 2. E had the dimensions 4 by 1. They want us to add. One of the rules states that you can only add and subtract matrices if they have the same dimensions. A and E do not have the same dimensions, so you simply cannot do that. Or you could write undefined. It's not possible. Now, one thing that they will try to do to kind of trick you is they'll give you a big problem like this, right? You'll be like, okay, I'm going to take the A matrix, I'm going to multiply it by 3, and then I'm going to subtract B, because that's in parentheses. Here, we're going to take 1/2 times C plus 4 times D, add those together. Ultimately, in order to perform this problem, in order to find a solution, you need to be able to take whatever you get from these steps and whatever you get from applying these steps and add them together. So if I look at this, if I take 3 times A, that just means I'm going to multiply a 3 into everything. So it'd still be a 2 by 2 minus a 2 by 2. So this works, okay? I can take 3 times A minus B. I would end up with a matrix that's a 2 by 2. Now if I take C, They want you to multiply every value by 1/2. They want you to multiply every value of d by 4 and then add them together. Well, I could perform this step, what's in the parentheses, because when you do scalar multiplying, it does not change the dimensions. So I would be able to combine those and I would get a 3 by 2. Here's the deal. Had you started this problem, you would have done a whole lot of work. When you got to this process, you cannot take a 2 by 2 plus a 3 by 2. So this is another problem where you cannot do this, because when you got down to the final steps, you would not have the same size matrix from this set of parentheses and this set of parentheses. So I only put this problem on here just to kind of give you a heads up before you get too far into a problem. Make sure you look and see that you could do the ending result. If they want you to add them or subtract them, you do have to have the same dimensions for the matrix. Okay, so if I kind of just look back at this page, we've talked about adding and subtracting. We know how to find the dimensions. You can add or subtract if you have the same dimensions. Scalar multiplying, you multiply by one value, that's called a scalar. It's just like distributing. If you end up having more than one operation, like we had in number 3, we have multiplication and addition. You do always have to follow the order of operations, just like any time you're doing math, you would multiply before you would add. Okay, now we're gonna go into something that's really, really fun. It says another basic matrix operation is matrix multiplication. And this is where you're actually multiplying two matrices together. Here again, it's very important that you know how to find the dimensions, because when you are multiplying, you have to find the dimensions of both matrices that you are trying to find the product of. The middle two numbers have to match, and that's what this would look like. So I'm going to show you. A is 1, 2, 3 rows by 1, 2 columns. B, 1, 2 rows by 2 columns. In order to multiply matrices, when you write out the dimensions, the middle two numbers have to match, like ours do. The 2 matches with the 2. If they match, then yes, we can find the product. To figure out the size of the product, meaning what is the dimensions of your matrix going to be, this is going to be a 3 by 2. So that means I go down 1, 2, 3, because this is how many horizontal rows I would have, by how many columns. So my solution is a 3 by 2. Now, in order to find the solution, you always use the first matrix, we use the rows. The second matrix, we use the column. So if I want to find the value that goes in row 1, column 1, I multiply row 1 by column 1. You multiply the first entries. So -1 times -3 is +3. There are more numbers in the row and column, so I add. Now I shift my finger over here and down here. 3 times -4 is -12. When you add those values, that gives you your value for row 1, column 1. +3 plus -12 is -9. Now if I want row 1, column 2, you take row 1 times column 2. You multiply the numbers. -1 times 2 is -2. Plus, shift over and shift down. 3 times 1 is 3. -2 plus 3 is 1. I'm done with the top row because I have both of my values for the top. So now I'm going to go to row 2. I have to go back to column 1. 4 times -3 is -12. Plus, -2 times -4 is 8. -12 plus 8 is -4. Now I want row 2, column 2. 4 times 2 is 8. Plus, -2 times 1 is -2. 8 plus a -2 is 6. So now I'm done with the second row. Now I have to go down to the third row, and I go back to column 1. 5 times -3 is -15. Plus, 0 times -4 is 0. -15 plus 0 is -15. Now I need row 3, column 2 to find my entry for row 3, column 2. That's the number that I need. So those are the two things that I have to multiply to get that. 5 times 2 is 10, plus 0 times 1 is 0. 10 plus 0 is 10. This is your product. So again, it might be a little bit tricky as you're first getting used to it, but once you get the hang of it, it's kind of fun. It almost feels like you're doing like a little puzzle. Okay, we're going to try a couple more. So E is a 2 by 2 because it's 2 rows by 2 columns. F is also a 2 by 2. They want us to find the product EF. So that means if I take the dimensions in that order, E, then F, the middle two values have to match, and they do. They're both a 2. This means I can multiply. To find out what my solution is going to be, you take the first and the last number when you stated your dimensions. So my solution has to be a 2 by 2. So again, the middle two numbers match. That just means I can find the product. These two numbers determine the size of my solution. So I have to be able to have 2 horizontal rows and 2 vertical rows. To find row 1, column 1, it's row 1 times column 1. Positive 3 times negative 1 is negative 3, plus 4 times 0 is 0. Negative 3 plus 1 is negative 3. Now I want row 1, column 2 to get that product right there. 3 times 2 is 6, plus 4 times 1 is 4. 6 plus 4 is 10. So now if you look in my product, I'm done with the top row. So I'm done multiplying using the top row. Now I need to go down to row 2. So in matrix E, I'm only going to be using row 2. So I can find the solutions for row 2. Row 2, column 1. Negative 2 times negative 1 is positive 2. Plus 5 times 0 is 0. 2 plus 0 is 2. Last value is row 2, column 2. Negative 2 times positive 2 is negative 4. 5 times 1 is 5. Negative 4 plus 5 is 1. There is your product. One thing that is kind of tricky with this, typically in math, when you are talking about the operations of addition and multiplication, we have that commutative property that says that you can multiply in any order you want. That is not the case when you are doing matrix multiplication. And this next example is going to show you that, okay? So if you want to find the product of BC, B has dimensions 1, 2, by 1, 2, 3. So B has the matrix dimensions, it's a 2 by 3. C is a 1, 2, 3. By 1, 2, 3. So if I am multiplying them in this order, BC, okay, that's the product that they want us to find. My middle two numbers match. So yes, I can find a product. My solution is going to be a 2 by 3, meaning I'm going to have 2 horizontal rows by 1, 2, 3 columns. So I'm looking for 6 values to find my solution. So to find row 1, column 1, it's the same thing. We just have 3 numbers this time. 1 times negative 2 is negative 2, plus, shift over, shift down. 0 times 1 is 0, plus, shift over, shift down. 3 times negative 1 is negative 3. Negative 2 plus 0 plus a negative 3 is negative 5. Done with column 1, row 1. Now I'm going to stay with row 1 and go to column 2. 1 times 4 is 4, plus 0 times 0 is 0, plus 3 times 1 is 3. 4 plus 0 plus 3 is 7. Last column, so last value in row 1. 1 times 2 is 2, plus 0 times 0 is 0, plus 3 times negative 1 is negative 3. 2 plus 0 plus negative 3 is negative 1. I have all of my values for the top row, so I'm done multiplying the top row. Now I'm going to go ahead to row 2 so I can find the solutions for row 2, starting back with column 1. 2 times negative 2 is negative 4, plus negative 1 times 1 is negative 1, plus negative 2 times negative 1 is 2. Negative 4 plus a negative 1 is negative 5, plus 2 more, I get negative 3. Now I want row 2, column 2. 2 times 4 is 8, plus negative 1 times 0 is 0, plus negative 2 times 1 is negative 2. 8 plus 0 plus negative 2 is 6. Last row, last column. 2 times 2 is 4, plus negative 1 times 0 is 0, plus negative 2 times negative 1 is 2. 4 plus 0 plus 2 is 6. There's the product. Now they want us to find CB, meaning we're going to reverse the order. So the dimensions for C, that's a 3 by 3. The dimensions for B is a 2 by 3. If you look at the two values in the middle, these do not match. So that means there is no product. That just goes to show you that when you're doing matrix multiplication, it's not commutative. You cannot switch the order of the matrices and end up with the same product. In fact, here we could take B times C and find a product. When we went and changed the order, it wasn't even possible. So today, again, we looked at matrix operations, adding, subtracting, multiplying by a scalar, finding a product of two matrices, as well as getting comfortable with stating the dimensions. So today you get a short book assignment to practice the skills. Tomorrow, just because to me this is really, really fun stuff. Tomorrow we're going to stay with the exact same ideas. You'll just have a worksheet workday, so you'll get to do some more matrix operations. I hope you guys are having a great Tuesday, and I will talk to you soon. Bye-bye.